Bismillahirrahmanirrahim. Hi everyone, I hope you are all doing well. I welcome you all in class of Real Analysis by Robert G. Bartle. My name is Azmat Ali. Our second chapter, the real number, is continue, and in the last lecture we covered up to question number 10. In today's lecture, from exercise 2.1, we will start from question number 11. So, the statement of question number 11a, we have to show that if a is a positive real number, then its reciprocal 1 over a is also positive, and 1 over a is equal to a. It is given that a is positive, it means a is non-zero. So 1 over a exists in R. Clearly you know only 0 has a no multiplicative inverse in R. As a is greater than 0, it means a clearly has a reciprocal 1 over a in R. So the first case, if we have to show 1 over a is positive, so for this we will show that this both inequality 1 over a equal to 0 and 1 over a less than 0, this both uh, expression do not hold here. So if 1 over a is equal to 0, I can write 1 is equal to 1 over a into a. As you know, a into 1 over a, this is equal to 1. But when you put 1 over a is equal to 0, because here 1 over a is 0 here, so when you put 1 over a is 0 here, this becomes 0 is equal to 1. That is not possible. So the first case 1 over a is equal to 0 is not valid. In the second case, when 1 over a is less than 0, again we can write 1 over a into a, this is equal to 1. But if you multiply this inequality by a on both sides, this becomes 1 a into 1 over a less than a into 0, because a is positive, so it will not reverse the sign of inequality. As a into 1 over a, this is equal to 1 and this is equal to 0. So now we have 1 less than 0. This is not possible because 1 is always greater than 0. So this case is also not valid. So there is only one valid case, that is if a is greater than 0, then its reciprocal will always greater than 0. Next we have to show that a is equal to 1 over a. In theorem 2.1.3a, we have read that uh, which says that if a, b are real numbers and if a is non-zero and a into b is equal to 1, then b can be written as 1 over a. This theorem says that if a and b are any two real numbers and a is one non-zero and the product of two numbers is 0, then one of them can be written as the reciprocal of the other. As here in our given problem, a is positive and its reciprocal is also positive, it means its reciprocal is non-zero. And a into 1 over a, this is equal to 0. So according to this theorem, I can write as one of them as a reciprocal of the other. So I can write a is equal to 1 over a, 1 over 1 over a. In simple words, if you replace here b is equal to a and a is equal to 1 over a, I can get the required result. Question 11b. In question number 11b, I have to show that if I have two number a and b, then their arithmetic mean always lies between these two numbers. That is a less than half of a plus b, a less than b. So to solve this, this is a very simple question. Given a less than b, adding a on both sides, we have a plus a less than a plus b. This is equal to 2a less than a plus b. Dividing on both sides by 2, this implies a less than a plus b over 2. Again consider this inequality. Now adding b on both sides, so this gives now a plus b less than 2b. This implies a plus b over 2 less than b. Combining 1 and 2, we have a less than a plus b over 2 less than b. So the arithmetic mean of two real number is always lies between those number. Question number 12. If a, b, c, d be the numbers satisfying 0 less than A less than B, mean to say both are positive. C less than C less than D and less than 0 means C and D both are negative. Give an example where AC less than BD and where BD less than AC. So in this question we have to just give an example by choosing any valid values of A and B that satisfy the given inequalities. Uh, I start here. Let A is equal to 1, B is equal to 2. You can see here 0 less than 1, 1 less than 2, that satisfied 0 less than A less than B. And I choose C is equal to minus 3 and D is equal to minus 2. Clearly minus 3 less than minus 2 less than 0, both are negative and satisfied C less than D less than 0. Now I have to find the value of AC and BD. AC, value of 1 is A is 1, C is 3 minus 3, so the product is minus 3, and the value of B is 2 and D is minus 2. Now the product is minus 4. Clearly you can see here minus 3 is greater than minus 4, that is AC is greater than BD. Now I just change the value of C and the remaining are same. Choose C is equal to minus 5 and D is minus 2. Clearly C is less than D is less than 0, minus 5 less than minus 2 less than 0. Now if I calculate AC, the value of A is 1, C is minus 5, this is minus 5, and BD 2 into minus 2, this is minus 4. Clearly AC is less than BD, that is minus 5 less than minus 4. Question number 13. This is also very simple question. In this question we have to show that if A and B are the two real number, then their sum of square is 0 if and only if the numbers are 0. Suppose let A and B both are 0. We show that A square plus B square is 0. Clearly when A and B both are 0, then clearly A square plus B square is equal to 0. By putting the value of A and B here, we have 0 square plus 0 square, which is equal to 0 clearly. Conversely, suppose that A square plus B square is equal to 0. Now we show that the number A and B both are 0. As we know that the sum of square of real number is 0 if the numbers are themselves 0. So this is the result in mathematics. This shows A square plus B is equal to 0. This implies A square is equal to 0 and B square is equal to 0. And further you can write it as A is equal to 0, B is equal to 0. That is required. Question number 14. If 0 less than or equal to A less than B, that is A is non-negative and less than B, show that A square is less than or equal to AB is less than B square. Show by an example that it does not follow that A square less than AB less than B square. Mean to say the strict inequality does not hold. The sign of inequality must involve in this inequality. Given 0 less than or equal to A less than B, this shows that A is greater than or equal to 0 and B is positive. Case number 1. When A is, I will divide this case into this inequality in two cases, when A is 0 and when A is greater than 0. When A is greater than 0, multiply 1 by A greater than 0 we multiply 1 by A greater than 0 because here A is greater than 0, so we will consider the inequality number 1 as 0 less than A is less than B, because here we are considering A is greater than 0. So when you multiply this inequality by A in each part, 0 into A this is 0, A into A this is A square, and A into B this is AB. Say this is inequality number 2. Multiply 1 by B greater than 0. Again multiply this inequality by B greater than 0. This gives 0 less than AB less than B square. Say this is my inequality number 3. Combining 2 and 3, combining these both inequality, we have 0 less than A square less than AB, and AB less than B square. Or ignoring 0, we have A square less than AB less than B square. Case number 2. If A is 0, then clearly A square is also 0 and A into B is also 0. So in case when A is 0, A square is equal to AB. Combining both cases, we have 0 less than or equal to A square less than or equal to AB less than B square, which is required. Now we give example in which we will show that this this inequality cannot be follow. A square less than AB less than B square. That is, we have to involve the equality sign in this inequality. So consider if A is 0 and B is 1, then you can see here A square is equal to 0 is equal to AB, because when you put A is 0 here and B is 1, this is equal to 0. This is less than B. If you take A is equal to 0, then A square is equal to 0. In this case, AB is equal to 0 into B is 1. This is equal to 0. This implies A square and AB both are equal, but these are less than B because B is 1. This shows that if 0 less than or equal to A less than B, then it is not possible that A square is just less than AB less than B square. It must be that A square is less than or equal to AB, and this is less than B. Sorry, this is B here. This was B. This was okay. This was the B square. So this is correct. This is B square. Question number 15. In question number 15, this is a same as question number. I think that was the question number 11. Question number 11b. In question number 11b, we have shown if A and B are any two real number, then their arithmetic mean is always lies between them. In question number 15, we will show that if A and B are a positive real number, then their geometric mean, the geometric mean of two real number is AB. If A and B both are positive, geometric mean always lies between A and B. And in the second part, we have to show 1 over A, B is less than 1 over A in case when A and B both are positive. If A and B both are negative, then this inequality will not hold. Given A and B both are positive, multiply 1 by A greater than 0 in 1, so it will not reverse the inequality. So we have 0 less than A square less than AB. Taking square root on both sides, we have square root of A square less than square root of AB. This is equal to simple A and this is equal to AB. So say this is inequality number 2. Similarly, now multiply 1 by B greater than 0. So we have 0 less than, multiply this inequality by B in each part. So this gives 0 less than AB less than B square. Taking square root on both sides, this gives square root of AB less than square root of B square. And square root of B square is equal to B because B is positive here. In this case, B square, square root of B square is just equal to B. Combining 2 and 3 both, we have in 2 we have A less than square root of AB, and in 3 square root of AB is less than B. So by combining both cases, we have A less than square root of AB, this is less than B as required. Now we show that if A and B both are positive real number, then their reciprocal 1 over B is less than 1 over A. Given that A and B both are greater than 0, if A and B both are greater than 0, it means their product AB also greater than 0. Then according to question number 11a, which says if A is greater than 0, then its reciprocal 1 over A is also greater than 0. So here, as AB is greater than 0, so its reciprocal 1 over AB will also greater than 0. Given inequality is 0 less than A less than B, multiply by 1 over AB greater than 0 on both sides. This gives 0 into 1 over AB, 1 over AB into A, 1 over AB into B. By cancelling out A, because A is positive, so there is no chance of 0 over 0 form. This becomes 1 over B and less than 1 over A as required. Next, question number 16 is a numerical type question. Find all the real numbers x satisfied in the following inequalities. X square greater than 3x plus 4. So I can write this inequality as x square minus 3x minus 4 greater than 0. And by factoring out, we have x minus 4 into x plus 1 greater than 0. These are the two factors of this quadratic expression. So now we have two cases. As this is a product is positive, So there are the two cases. Uh, you know that if the product AB is greater than 0, this is possible if both A and B are greater than 0 or both A and B are less than 0. So the first case, if both are positive, that is x minus 4 is positive and x plus 1 both are positive. So x minus 4 greater than 0 mean x is greater than 4 and x plus 1 greater than 0 mean x is greater than minus 1. Uh, I am representing these inequalities on a number line. This is my x is equal to minus 1, and as x is equal to minus 1 is not included, so that's why I am putting here a hole here. So x greater than minus 1 mean the numbers are on the positive infinity. So the above line, this line shows x greater than minus 1, while x greater than 4 mean the number are greater than 4 and it will be to the side of positive infinity. So the below line, this line shows x greater than 4. Now the common region in both number lines are this. This is the common region. This region is not a common here. So the common region is given by x greater than 4 in this case. Case number 2. When both of the factor x minus 4 and x plus 1 are negative, this gives x less than 4 and this is equal to x less than minus 1. Now x less than minus 1 mean this is the region to the negative side of infinity, and x less than 4, this also shows the number are on the negative side. Now the common region is x less than minus 1 because this region is not a common in both inequalities. So the common region is given by x less than minus 1. Hence, from both cases, solution of the given inequality is in the first case, the solution region is x greater than 4. X greater than 4 means all those values which are greater than 4 mean 4 to infinity. And here x less than minus 1 mean all those values which are less than minus 1. So these are minus infinity to minus 1. So this is the union of two open interval minus infinity to minus 1, 2 and 4 to infinity. Question B part. Given that 1 less than x square less than 4, break the inequality in two parts. One less than x square and the second is x square less than 4. Consider the first part, 1 is less than x square, or you can write it as x square greater than 1, taking square root on both sides, x square square root greater than square root of 1. In case of inequality, we can change x square root of x square by x absolute. So we can write it as x absolute greater than 1. Now we have a result x absolute. If x absolute is greater than a, where a is a positive real number, then you can open this as x less than minus a or x greater than plus a. So this can be written as x greater than 1 or x less than minus 1. Now consider the second part of this, x less than 4. So when x less than 4, taking square root on both sides, this gives this can be written as x absolute, and 4 absolute is equal to 2. Now using the result x absolute is less than a is given by minus a less than x less than plus a. So you can write it as minus 2 less than x less than plus 2. Plotting all of these regions on a number line, the first region is x greater than 1, the second is x less than minus 1, and the third one is minus 2 to plus 2. Now you can observe that the common region are this one is a common in these two inequalities, in these two portion, and this region is common in these two portion. So the common regions are minus 2 to minus 1, and the second region is 1 to 2. Hence our solution set lies between minus 2 to minus 1 union 1 to 2. Further, you can verify that by choosing any value from the solution set and plugging that value in the given inequality. If the value satisfied the given inequality, it means you have correctly found the solution. For example, if one put x is equal to 0, if put x is equal to 0 here, this gives 1 less than 0 square less than 4, This is equal to 1 less than 0, 0 less than 4. Half of the inequality portion is correct, that is 0 is less than 4, this is correct, but 1 less than 0, this is not correct. It means you are choosing the wrong value from the solution set. X equal to 0 cannot be entered in the solution set. C, question number C. This is very interesting question, and I have seen many students solve this question wrongly. Here 1 over x is less than x. Uh, some of the students just multiply this inequality by x. This is equal to, this gives 1 over 1 less than x square, and then they can write it as x square greater than 1. So the first mistake is that they do not consider the both cases, because here it is understood that x is non-zero. X cannot be 0 here, but this is possible that x is greater than 0 and x is less than 0. X either is positive and negative both. So we will consider both of the cases. When x is positive, so when you multiply this inequality, in this case the sign of inequality will not change. So it gives x into 1 over x less than x into x. This is equal to 1 and this is less than x square. Or you can write it as x square greater than 1. Now the second mistake that students do here, when they take square root on both sides, uh, as previously in question I have discussed that you can write it as x absolute, and this is equal to 1. Now they use the result x absolute greater than a, so they write it as x less than minus 1 and x or x greater than 1. So they include both, they include in the solution set both of the values, x, both of the parts, x greater than 1 and x less than minus 1. While the correct reason is that because x is greater than 0, there is no need to use this formula here. When your x is positive, you will take just square root on both sides, and this gives x greater than 1. There is no need to use this concept here. You will use this concept when your x is a real number, and you are using at the same time, x is positive and negative, either it is positive or negative. I am separating this question in two cases. Next, when your x is less than 0, now when you multiply this inequality by x, it will reverse the sign. Now the sign will become greater than, or this can be written as 1 greater than x square or x square less than 1. So by taking square root on both sides, this gives x absolute less than 1. Now this can be written as minus 1 less than x, x less than 1, but my x is less than 0, so it squeeze the interval minus 1 to x, x less than 0, because my x is negative here. So I cannot take the positive value here. So the common mistake that students do here, when they take square root on both sides directly, uh, they can write it as x less than 1. But this is wrong, because now x is negative here. So now I will take both parts, negative and positive, and after this, because my x is negative, so I will split this whole interval into 2 into minus 1 to 0. So this is a very sensitive question in this sense, because here x is less than 0, so negative values of x are valid. Combining both cases, we have x belong to minus 1 to 0, union 1 to infinity. The second method to solve this question, you can convert this question into a single rational form, 1 over x minus x less than 0. This gives 1 minus x square over x less than 0. That can leads to the same conclusion. The last part of question number 16. In this question, our inequality is 1 over x less than x square. I will do this part also as the same as the C part. When x is positive, multiply on both sides by x, the sign of inequality will not change. This gives 1 less than x cube, or x cube is greater than 1. Taking cube root on both sides, the cube root of 1 is 1. This implies x is greater than 1, or x greater than 1 mean x belong to 1 to infinity, because in this case our x is positive, so we will take all positive values. As x is greater than 1 means this also shows positive values. Case number 2, when x is less than 0. Now I will assume all those values which are less than 0. So when we multiply x on both sides, now the sign of inequality will change, and it changes to greater than sign. So this becomes 1 greater than x cube, or x cube is less than 1. Taking cube root on both sides, this gives x less than 1. X less than 1 mean minus infinity to 1. But my x is less than 0, so I will squeeze this interval into from minus infinity to 1 to minus infinity to 0. My interval is, my original interval is minus infinity to 1, but my x is less than 0, so I will squeeze this interval from minus infinity to 0. Now combining both of the values, first is 1 to infinity and the second is minus infinity to 0. So this is the solution of the given inequality. So the last two parts are very sensitive. Uh, so in the total lecture, we have discussed question number 11 to question number 16. Inshallah, in the next lecture, we will start from question number 17. If you find my video helpful, kindly like, share, and subscribe my channel. So see you in the next lecture. Take care. Allah Hafiz.